All right, so here is what is it, 3.9 quadratic inequalities in one variable. I'm not sure which way your teacher is doing this, if he's using a lot of graphs like I have over here on my screen, um, or if you guys are making what we call sign graphs, essentially. I'm going to do it because it does here, it says hint, make sure, or hint, to make this problem easier, generate a table on your calculator using uh, that equation right there. And so what I did is I've graphed it right here. Okay. And so I'll keep referring to the graph. And what I've done now is I'm going to close that here. And I've got an image of that exact graph that I'll add. So as I talk about this, I can reference it. So let's see if I can find it here. All right. So there's my Desmos graph of the equation that we have in number one. Okay. So what I'm going to do is I will show you how I do it from a graph. Then I'll show you how you do it find the solution sets without doing it with the calculator, but then I'll do it all with the calculator. Okay, so this graph right here, you can see the actual equation has no y's in it. This is just saying, hey, I want to know oops, there we go. I just want to know when this x squared plus x minus 2 is greater than or equal to 0. So if we're going to use our calculators, what we do is instead of graphing 0 here is we just make sure it equals 0, then replaces 0 uh, with a y and just graph it like it's an equation. Y equals x squared plus x minus 2. And so you can see I've done that. But now this graph, and you can see I've highlighted my, there's my x-axis really dark and my y-axis really dark black, so you can identify those. But there's some key points right there. And those are your x-intercepts, and that's what you've been finding in some of your other homework. And so in this case, hey, right when x is 1, this function equals 0. So in this inequality, had this meant equals, we'd say, hey, when x is 1, the y value is exactly 0. And we'd say, hey, when x is negative 2, the y value is exactly 0. So uh, if the equation had been x squared plus x minus 2, when do you equal 0? We'd say when x is negative 2 or when x is 1. The question's changed now. It's asking, not when are the y values 0, now it's asking when are the y values, which this equation calculates, when are the y values greater than 0. And what's cool is once you identify where the y value is exactly 0, then you just have to decide if you want things that are taller or bigger than 0. These are this section of the graph. Or if you want things that are less than 0, and that would be this middle section. Right there it's 0. And so these are negative y values. And the x's right in here, like negative a half and negative 3/4, those are the x's that give you these negative answers. And right in between this 0 and this 1 right here, uh, like a half, those give you these fraction or these negative y values. As soon as you go step right to the right of the 1, these x values, they map up to positive y values. And to the left of negative 2 here, they map up to positive y values. So essentially, when I look at this equation and I look at this graph, it says, hey, what x values give you positive y values, give you greater than 0 results? And so I can just look at the graph and I say, well, when x's are less than this 0 right here, so when x's are less than negative 2, or when I'm on the right side of that 0, so when x's are greater than 1. Notice I don't have greater than or equal to 1 because at 1, it equals 0. And they just want to know when it's greater than 0. But this just tells me how to find which point it is now, right? Let's see where 0. Well, 0 is not greater than 1, and 0 is not less than negative 2. In fact, 0 maps to a negative y value, and we want things that are greater than 0. Clearly not that. At negative 2, we map to exactly 0, so we don't want that. At negative 4, we're way out here, but negative 4s are less than negative 2, so they're going to map way up there to positive y values, and that's the answer we want. Okay, I can't quite read what that one is, so if that's less than negative 2 or greater than 1, you've got your another option that you could answer. Which one is not a solution to the set of this inequality? So we got 5x squared plus 35 is less than or equal to 0. Oh, I did say I would tell you how to do this without a graphing calculator. Let me show you a few more with a calculator, uh, and then we'll look at without a calculator. So I'm going to now get rid of this thing right here if I can. Open up my Desmos again. There he is. And let's see here. For equation number 2, it is that one right there. And he's kind of hard to see. I'm going to spread my, shrink it down here just a little bit. There we go. There's the bottom of him. Hopefully you can tell where he's at now. Okay. And we'll just take a quick picture of him. We'll add him to our, there we go. So another one of these things. Let's see what they want us to figure out for second problem here. Number 2, they want to know when is this 5x squared plus 35x, when is it less than or equal to 0? So we're doing less than or equal to right there. So I'm looking for, again, those zeros. I want to identify those right away. So, okay, right here it crosses the x-axis, not with that pen, but right here and right here. And this is when x is 0. And this one right here is when x is equal to, gosh, it's hard to tell that, right? So I could go back to my graph. If I've done this in Desmos, which I have, I should have done this before I took the picture, but I can just tap those points and see it tells me at -7 is that other 0. But even if I don't know that because I didn't use Desmos the right way and I forgot to write it down, remember, we know how to find out where they equal 0. There's another x in here, okay? So this is like solving a quadratic equation, which you've done and we've been working on because we've seen those lessons. And so if I wanted to solve this equation, for example, and find it 0, I would first look to check for a GCF, and I can see 5 and 35, they're both divisible by 5. So I could reduce this equation like so. And then I would look for a GCF and see I can take an x out of both these terms. This is still x times x is x squared, and x times 7 is 7x. And so right away I can find the actual 0. So I know myself, even without my calculator, this graph crosses the x-axis at 0 and -7 over here. Now it wants us to figure out which one of these x values give us values that are less than 0. Well, we can see exactly where these answers are now. Right at -7, I'm 0. To the left, I'm positive numbers. To the right of 0, I'm positive numbers. In between -7 and 0, these are all negative y values, so they are all less than 0. And so any x between 0 and -7 is going to produce numbers that are less than or equal to 0. And so right at -7, 0 is the solution, and everything in between, including 0. All right, hopefully you can see what I'm talking about there. So if I look at their choices, I'm trying to be between 0 and -7. So I'm trying to pick a number between those two things, the -7 and the 0. -1 is between -7 and 0. 2 is not. 2 would give you a positive number out. 0 is equal to 0, right? It includes, so if x is 0, you get 0, which would make this inequality true. And I can't tell what that one is, but it might have been a -7. If it was a -7, then that does make it equal 0, which we want to include. Okay, so check that number right there. I can't tell what he is. Real quick now, let me show you how you do this without a calculator. 5x squared plus 35x. I don't believe he did this. I want to know when it's less than or equal to 0. If you were doing this without a calculator, this is the way that math looks. You just basically solve it, just like I showed you earlier, except notice I'm leaving that inequality there. And when I do this, I get, my factorization. Then what we do is we make what's called a number or a sign table. And I've got x could be 0, and I've shown you how to do that, or x could be -7. And so I mark those two numbers on my table. And then This kind of looks like this. I don't want to close that off. This is a number line right here. Okay, so this is 0, so like 1's over here and 2's over here and negative 1's here all the way down to -7, etc. But we don't want to fill it all out because it just takes too much space. So what we generally do is just put those 0 marks on it. It tells us where negative is to the left and positive is to the right. Now I like to put them up on top. Now I'll show you why in a second. So here's my -7 and my 0. And then what we do is we take each of these factors, x, we line it up to the left-hand side, and x plus 7. And what we do is we just look at what happens. This is like my x numbers here. What happens to each of these factors when I plug in numbers that are in this position or this position or this position on the number line? So if I put in a number like -8 in for x here, that would make x a -8, and that would be a negative number. Okay, and in fact now, what I'm saying here is that if I plug anything to the left of -7 into this factor, I get negative numbers out. So I plugged in a -8 because that's less than -7. It'd be over here on the number line. If I plug in -8 into this green factor, it's -8 plus 7. That would be a negative number. So what this is telling me is that when I plug x's into the first factor over here on the number line, they give me negative answers out. When I plug in the same x's to the green factor, they give me negative answers out. And therefore, the product, which I'm trying to figure out when is it less than or equal to 0, the product for these x values, when I plug them into the equation, will be a negative number times a negative number, which means my polynomial, the whole thing, will give me positive answers when I plug in -8, -9, -10. Hey, that's a negative number times a negative, so you get positive results. Negative times negative is positive. So those aren't where my answers are because I want x's that give me negative numbers, things that are less than 0. And these are giving me positives. Right? Then I look in the next region. The next region is between -7 and 0. So I pick a number in this region. You can pick any number. So you pick the easiest. I would pick like -1 because ones are easy to do math with. So I put a -1 in for x. That would give me a -1 out, which is a negative number. So this will still be a negative region for that factor. -1 into this one, though, would give me a -1 plus 7. This would give me positive results. And again, I could pick any x in this region and it'd still be positive. So like -6 right here, -6 plus 7 is positive. Right at -7, this factor, or this whole thing equals 0. And at 0, it equals 0. Right? We already knew these were the zeros. Let's see, so in this region, I'd get a negative result. And then I plug in numbers bigger than 0, like 1, positive 1. That'd be a positive 1 for the x. So that's a positive number. And if I plug in a positive 1 into the green, that comes out positive 8, or a positive number in general. And that product then would be positive. And so when is my function negative? When is it less than or equal to 0? From at -7 and at 1 and everything in between gives me negative numbers. So that'd be my solution set. And that's what my graph is showing too. It's saying, hey, anything between -7 and 1, or 0 rather, gives me negative y values. So that's how you do it. And I'll just keep doing them, I don't know, whichever way seems best for each problem as I go. Solution set of x squared greater than 25, which of the following is the solution set? So a problem like this, you could throw it right into a calculator, but hopefully it'll teach you this, or has taught you this. I would, get it. So it says greater than or equal to, just greater than 0. So I've subtracted 25 from both sides. I would now factor this polynomial. So it's x minus 5 times x plus 5, right? A difference of squares. And then, instead of using my calculator for this one, you guys have worked with translations and how graphs moves. This thing has a 0 at 5 and at -5. So -5 is a 0, +5 is a 0. This graph opens up. It's just a positive lead coefficient. So this graph is just going to look like this. Don't even need a calculator to know that because I know it opens up because of the positive lead coefficient. And so now I can see when x's are less than -5, I'm getting positive y values. To the right of -5, I'm producing negative y values until I get to 5. At 5, I'm exactly 0. And then to the right of 5, greater than 5, I'm getting positive numbers out. They want to know what x values cause my function to be negative. Well, that would be all the x's in between this 0 at -5 for the x value until I get to this positive 5. So I'm really answering it's these x's that are producing these negative values. Where are those x's at? They're trapped in between -5 and 5, which looks like, see, we want to be less than 0. Yeah, so we're trapped in between them. So it looks to me like none of these are, oh, I jumped down to number 9, sorry. There we go. Not, there we go. Oops, I'm not trapped. I am trapped between -5 and 5, but this includes the endpoints, and I don't want to include the endpoints. Oh, shoot, sorry. I'm answering wrong. I was answering when is it less than 0. I gotta pause. I don't know if I can edit that. I'm trying to record it a different way. So, I'll try and leave a note when I text you. Hope that worked. So I was answering when is it less than 0. It wants when is it greater than 0. So it's greater than 0 when the x's are out here, less than the -5, because there, remember this parabola keeps getting wider this way. So as it goes up and my x's go further left, my y values get more and more positive. And that's what they wanted, greater than 0. The same thing happens over here on the right. As x's go this way, my graph is getting really tall and high. These are all positive y values. So my answers are to the left of the -5 and to the right of the +5. So let's see here. Better to use this guy here. So this interval notation is saying, hey, -5 all the way to -infinity and +5 all the way to +infinity. It's this graph right here on my little number line I drew. All right, this is an awful lot to try and teach you in a video here. The solution to this one, same deal. That's a difference of squares, x minus 3, x plus 3. This one, they do want to know when it's less than 0. There's your intercepts at -3 and +3. It opens upward. So now, to be negative, we are trapped in between the -3 and +3. So this is a trap one. Let's see here. It looks right. This isn't written very well. It's hard to read, I think. But there we are. We're trapped in between -3 and 3. Ooh, we can't include them, though. Right? These are open circles because I want to be less than 0 but not equal to it. So I want this guy here at -3 and +3 and everything in between. That's what gives me these negative numbers, and that means they are less than 0. Next one, number 5. Oh, wonderful. They already factored it. So where is it less than 0? Quick graph, right? Remember, when you make your quick graph, you got to use what makes the factor 0. So x equals -5. And x minus 3 equals 0. So x equals 3. Wish those colors were a little darker there. -5 and 3. Let's see here. My graph opens up. So it's a parabola like this. When is it negative? When the x values are between this -5 and this 3, I get y values that are negative. And that's what they want. When are they less than 0? When are they below that x-axis? So between -5 and 3. Oh, using inequality notation here. We are trapped. So we're going to be trapped between the -5 and the 3, and we do not want to include them because they just want to know when you're less than 0, but not when you're equal to it. Let's just match him. It looks like that's answer A right there, I think. Another inequality solution set. Notice this one doesn't equal 0, and you just always want to get it equal to 0. So I subtract the 5x from both sides. I subtract the 24 from both sides. It's hard to read that. But I get x squared. The 5x would now be negative on the left, and the 24 would be negative. Oops, and I want to be greater than or equal to 0 at that point. Let's see here. We'll try and factor it. So x and x, that's the easy one. We need to multiply to 24, so you'd make a little list here. Like in 3 times 8, if the 8 is negative, those two numbers add it to negative 5, the middle guy right there. So it's a 3 times an 8. The 8 is negative, the 3 is positive. I want it to be more than 0. I draw a quick sketch. X is negative 3. That's a 0 right there. X is equal to 8, and I just jump out there to 8 and say that's a 0 right there. Now those are filled in spots. I'm circling them to remind you that that says y is 0 right there. Y is 0. At what value? X is 8. At x is negative 3. Graph opens up again. Hopefully they'll have one that opens down because that flip-flops this idea. They want to know when is it greater than or equal to 0. Equal to 0 right here. Greater than 0 here. And again, remember, we're trying to describe the x values that cause this. So the first x that makes this 0 is negative 3, and then x's to the left of it cause these y values that are positive. Okay? And then right here at 8, I'm exactly equal to 0, which they want. And then greater than 0 occurs when I enter these x's out here. They produce these positive y values. So there's kind of my number line for my solutions. X's have to be less than or equal to the negative 3, or x's have to be greater than or equal to the 8. See here, less than or equal to negative 3, greater than or equal to 8. That looks like you're a winner. Ooh, I'm all over the place today. Find the solution set to each of the quadratic inequalities shown below. Represent your solution set both in set builder notation and graphically on a number line. You should probably practice these things, but I'm going to go ahead and whittle them out here real quick. This guy right here, as I start to try to solve him, the first thing I notice is he's got that 2 in front of it. And so I would check to see if everybody's divisible by 2, and they're not. Okay, so I'm just going to factor in real quick here. Remember, if your a value is not a 1, this is a 2. So when I do this, I go 2x and 2x. I do a times c. 2 times negative 35 is negative 70. I'm looking for two numbers, r and s. They have to add up to that negative 70. Okay. Oops, no, sorry. They have to multiply to that negative 70. But they have to add up to the b term, the 9. So when you do this, you always make your multiplication list first. 2 and 35, 3 doesn't go into 70, 4 doesn't, 5 does. 5 goes in there, 14 times? There we go. 5 and 14 have a difference of 9. I'm going to make the 14 positive, the 5 negative. So those two add up to 9. And yet 5 times negative 14 gives you negative 70. So one of these is negative 5. One of these is 14. The second one, these can both be divisible by 2. These aren't. So either one, whichever one is divisible, or sometimes both, just divide it away, get rid of that number. Okay, and that is the correct factorization now for that trinomial. If he has a different way your teacher does for factoring it, use his method. Okay, so now I'm going to find my zeros. What makes this one 0? So add 5, divide by 2. 5 halves, or 2.5 is probably easier for us to graph. Again, I'm just setting them equal to 0 to find out where they cross the x-axis, subtract 7 there. Because once I know where they cross the x-axis, I know where the change from positive y's to negative values come out. So at 2.5, I hit the y-axis. Oops, sorry, negative 7, I hit the y-axis over here. And at 2.5, a little closer to the y-axis, I also have 0. So there's my zeros. It opens up, so this parabola is negative down here, but it's positive and positive here. Okay, let's make the negative part down there. All right, what do they want it to be? They want your x's to be producing negative values out. So x's have to be in between negative 7 and 2.5 to give me less than 0 values. All right, two different ways to write the answer. Okay, the number line, graphically, I'm trapped between negative 7 and 2.5. I do not want to include them because it says less than 0, not equal to it. So these are open circles, and I'm trapped in between those two numbers. And I assume his set builder notation is x. So using a straight line, let's take a peek over here. There's his set builder notation. All right. Using just a vertical separator here, and x is trapped. Always put your small number on the left. -7 is smaller than 2.5 when it's a and statement like that. So there we go. This would be the same as writing this interval notation. Okay, so there is graph, there is set builder, and there is interval. Same deal with this next one. This is kind of a classic one here. Subtract your 5x from both sides, subtract your 6. I say classic because this one right here always throws students x and x. Everybody gets that. But it's this 6 here. Some students say, hey, it's a 1 times 6. And they go, because 1 and 6 make 5. Some students go, hey, it's a 2 times 3, because 2 and 3 could add up to 5. It's always one of those. You just got to figure out which one it is. So if I put a 1 here and a 6 there, let's see. To get a -5, that'd have to be a -6, because then those two would add up to -5. So that's the factorization for this one. Let me show you why 2 and 3 don't work for this particular one. Sometimes it does. It just depends when where these negative signs are situated. A lot of students would try 2 times 3, and you'd say, hey, they could both be negative, and then they add up to -5, which is fine, but then they do not multiply to the -6. So that's why -2 and -3 do not work for this one. All right, but we found them, so x equals -1 is 1, 0, x equals 6 is the other 0. Here's the quick graph, -1 and 6. See here, it's going to cross the x-axis right there. That's where the function equals 0. This is where it's greater than 0. This should say greater than here. This is when it's greater than 0. And here is where it is less than 0. These x values, I want this one to be greater than 0. And so I want the reds here. So on a number line, I want those x's. And where it equals 0, yes. And I want these x's. So number line, left of -1, include the -1. And 6, include the 6. And go to the right. It's a 6 right there. Let's set build it. X. It's a terrible looking curly bracket. There we go. X's. And the x's are less than -1 or equal to it. Or they are greater than or equal to 6. There we go. That's not too bad. You get the idea, I hope. I'll do one of these big ones. I'll do C, and I'll do F here. I'll leave the other two to you. All right, so I got myself a quadratic here. I want 0 on this side. And so I'm going to subtract 10x and add 5. You can do these two steps at once. Beautiful. X squared plus 40x. The 5's add up to 0. That cancels out. Look at this guy. If I look real close here, divisible by 8, divisible by 8. So you want to do that. Note the 0 on the other side. That thing's divisible by anything, so I don't even care about it. There we go. 0. Nice, easy factorization. Just take out a GCF. That's an x. First factor could equal 0. Second factor could equal 0. This one I have to solve. I've got my graph now because I know it crosses when x is 0 and when x is -5. It opens up. So there, I should do that in red for my positive y values and my positive y values and my negative y values. I solved this one for it wants to be less than 0, so I want my black x values here, the ones in between, the -5 and the 0. And let's see here, I don't want to equal 0, I just want to be less than it. So those are open circles, because at those numbers, it equals 0. There's the graph. Set build it x bracket, I'm trapped. So when you're trapped, just put your small number on the left big number on the right. I mean trapped when I say that we're caught in between these two numbers, trapped in between them. Small number on the left, big number on the right, even though 0 is not very big, and always point left so that x is bigger than the small number and x is less than the big number. Close it with an end bracket. And the last one I thought that looked kind of tough was maybe F here. Lots of stuff going on here. I want to move all this to the left so I have a 0 on the right. You can go the other direction as well. I'm going to do all these at once. Right, it's just one after the other you'd end up doing, so you just end up doing them all at once. Making sure you line up like terms where they go. Giving us a final new equation, or equivalent equation, I should say. Oh, the x's disappear. Beautiful. Let's see here. They're trying to trick you here with a difference of squares problem. This is a tricky one. It's got to be a 2x and a 2x to give you 4x squared. It's got to be a 1 times a 1 to give you the 1. But notice there's no middle term. That's because these add up to 0, which means 1 is negative and 1 is positive. It is a difference of squares. This is like a 2x squared minus a 1 that's been squared. 2x minus 1, 2x plus 1. All right, we're trying to get this thing greater than 0. So I again find the zeros. Where does this exactly equal 0? At x is a half. This one solves to give me the negative a half. So this graph, and then you just make your negative half and half really big, right? They don't have to be really close. You can label them x as a half and draw as big a gap as you want to there. So right at negative half on 0, positive half on 0, it opens up. So there's the, any x's out here cause me to have positive y values. Any x's out here, positive y values. X's in this little region, they cause these negative y values. What do they want us to have? Greater than 0. They want this positive stuff. Oops, didn't want to erase, wanted to circle. So let's see, where's that positive at? When x's are less than the negative 1/2, or when x's are greater than the 1/2. That's when I'm greater than 0. X is over here, trying to erase it. X is over here, cause positives, and x is over there, called positive. All right, final answer then. Let's see, number line. There's negative a half, and I gotta be less than it, not equal to it, because I don't want to equal 0 for my y value, or greater than positive a half. And set builder, this is an or statement, so we go x's have to be less than negative a half, or the x's have to be greater than positive a half. Hopefully that helps you out. That was pretty quick, and good luck. Hope you have a great couple of days at school.